Hey! It's now time to graph those rational functions. We've done a lot of stuff to get to this point, knowing where to find things, all the characteristics, manipulating these functions. So now we get to do the graphing, which is exciting. So let's go ahead, but now I'm going to give you a few steps because we want to make sure we're including all the things that need to happen here. So there's quite a few steps, and I'm not ever going to ask you to memorize these steps. I will prompt you for these so that we are looking at all the characteristics and they are represented in our graphs. The first step that we're going to look for is the vertical asymptotes and holes. We'll factor everything. Any of the factors that are in common in the numerator and the denominator are going to give us holes, and we're going to find out where that hole is. Now, if there's a factor in the denominator that is 0, that's our vertical asymptote. So we would say x cannot equal this number, but x equals this is the line of our vertical asymptote. The next step then is we're going to find the y-intercepts. We'll set x equal to 0 and solve for y. There may be 1 or more or 0 y-intercepts. The third step then is to find the x-intercept. And this one we're going to set the numerator equal to 0. We're going to ignore the denominator completely and then solve for x. We also want to find our horizontal and slant asymptotes. And remember, we have n is less than m, our horizontal asymptote will be y equals 0. If n equals m, our horizontal asymptote will be the leading coefficient of the numerator a divided by the leading coefficient of the numerator b. And if n is greater than m, there's not going to be a horizontal asymptote. And if n is greater than m by 1, there is a slant asymptote, and we're going to use long division, and the slant asymptote will equal the quotient of our division problem. We also want to check to see if there's an asymptote intercept for the horizontal or slant asymptotes. There's never going to be an asymptote intercept for a vertical asymptote. So we're going to take whatever that asymptote is and set it equal to f of x and solve for x. If it's possible, if it's not an identity, then that's the location that the graph actually intercepts the asymptote. We're going to find a few additional points, just to know what's going on in those gray regions that we're not quite sure what's happening. Just set up an XY table for that. Once you have all that information, then we're ready to graph the function, taking sure that our function illustrates every single one of these points that we have found. And if you are asked to, please state the domain. Okay, we're going to start graphing now. We've got the function f of x equals 2x squared times x plus 1 in the numerator being divided by x squared minus 9 times x plus 1 in that denominator. And you may have to put this in. I think I have a typo on my notes. So let's factor this. The numerator is already factored, 2x squared times x plus 1. In the denominator, x squared minus 9 can factor into x plus 3 times x minus 3. And we still have that x plus 1. So the first thing we're going to look for is vertical asymptotes and holes. Well, at x plus 1, because that cancels out, there's going to be a hole. So x plus 1 equals 0. So x is going to equal negative 1 at the hole. And we want to know what that would be. So we're going to put negative 1 in our canceled one, our simplified. So negative 1 squared is 1. 2 times 1 is 2. I'll put that over here in the numerator. Negative 1 times, or plus 3 is 2. And negative 1 minus 3 is negative 4. So 2 over negative 8. So negative 1/4 when simplified is the y coordinate of our hole. So we're going to put a hole at negative 1, negative 1/4, right about here. Our vertical asymptotes, we're going to have two of them right here and here, are going to be x equals negative 3 and x equals 3. So bear with my lovely drawings on the computer. We're going to put dashed lines at x equals negative 3 and at x equals 3. Now I want to find my x-intercept. I know it's a little bit out of order. I'm going with the steps that I gave you. So we're going to set 0, x equal to 0. So 2x squared when x is 0 is 0. 0 plus 1 is 1, so we have 1 in the numerator. And negative 9 times 1 in the denominator, so it's negative 1/9. Oh, I am so wrong because when this is 0, it's going to be 0 times 1. So that doesn't occur. When 0 times anything, it's going to be 0, so my x-intercept is 0. It's going to occur at the point 0, 0. That's also then going to be my y-intercept. If I have set this equal to 0, that 2x squared times x plus 1, the numerator, equals 0. 2x squared would be 0, and if I do x plus 1 equals 0, oh, that was canceled out, right? Because we did that, so I don't use that for finding my x-intercept because there's a hole. So my cross is at the same place, right there at the origin. The next thing I want to find is, we did the x and the y-intercept. Let's find our horizontal and slant asymptotes. So the leading term, after we've canceled these out, is 2x squared over x squared. So n is equal to m, and if n is equal to m, then y is going to be a over b. A is 2, b is 1, so y equals 2. And I'm going to draw that asymptote. So we have a horizontal asymptote at y equals 2. If we have a horizontal asymptote, we don't have a slant asymptote. So if I put this whole thing, or the simplified one, 2x squared over x squared minus 9, and set that equal to 2, well, I'm going to multiply that by x squared minus 9. So I get 2x squared equals 2x squared minus 9. This is an identity, so there is no asymptote intercept. And I'm going to then kind of get some few points, and I'll graph it, and it looks like this. And I would state my domain as being all real numbers except for my holes and asymptotes, vertical asymptotes. So I'm going to go from negative infinity to negative 3, and then from negative 3 to 0, or negative 1, sorry, negative 1, because that's where the hole is, and then negative 1 to 3, that's my other vertical asymptote, and then 3 to infinity. We have another function to graph. F of x is equal to x minus 4 in the numerator, and x squared minus x minus 6 in the denominator. X minus 4 is prime, so I'm just going to leave that in the numerator. And I can factor x squared minus x minus 6 into x minus 3, x plus 2. There are no factors common in the numerator or the denominator, so we have no holes. Our vertical asymptotes will be when I set the denominator factors equal to 0, So they would be x equals 3 and x equals -1. So I would draw those dashed lines to indicate our vertical asymptotes. And -1. And let's look for our y-intercept when x is 0. So we'd have 0, 0 minus 4 is -4. 0 minus 3 is -3. And 0 plus 2 is 2. So that gives us -4 over -6, or a positive 2/3. So our y-intercept is going to be 0, 2/3. And we can put a point there. 0, 2/3 is about there. Our y-intercept, our x-intercept is when x equals, we take that numerator, x minus 4, set that equal to 0, and it's going to be x is equal to 4 when y is 0. So x is going to be 4, 0, we'll have that point there. Let's see if there's a horizontal asymptote. Our leading term is x in the numerator and x squared in the denominator. So n is less than m. So it's automatically going to be y equals 0. So that would be the horizontal axis, the x-axis. Since we have a horizontal asymptote, we will not have a slant asymptote. And if I set that numerator equal to 0, x minus 4, we already did that for the x-intercept. That is also the asymptote intercept, since the x-axis is the horizontal asymptote. So I'm going to label that as the asymptote intercept. And my domain is going to be all real numbers except for our exclusions, which are our vertical asymptotes. So x, oops, I'm sorry, -infinity to -1, -1 to 3, and 3 to infinity. And we can put that on the graph. That looks something like that. Oh, I just now noticed that that should be a 2. I didn't read my own writing. So that's a 2, and that's why it's at x equals -2 instead of -1. Let's take a look at our last function that we're going to graph. We've got f of x equals 2x squared minus 5x plus 7, and then x minus 2 in the denominator. This numerator is prime. It does not factor. So we have no factors in common. So no factors in common means there's no wholes at all. That denominator, if we set that equal to 0, make that 2 look like a 2 instead of a 1 this time, is going to be at x equals 2. So my vertical asymptote is at x equals 2. My y-intercept is going to be when x is 0. So this term is 0, this term is 0, this term is 0, and I have 7 over -2. So it's going to be at 0, -7 halves. So at 0, -7 halves, about here. Oh, that's 0. There we go, about here. Now, because of the x-intercept, we're not going to have any. Since that numerator is prime, we can't set it to equal to 0 and get a real solution. So since there's no real numbers, there is not an x-intercept. So we're not going to have a point on the x-axis. Let's look for a horizontal asymptote. Our leading coefficient or leading term in the numerator is 2x squared, and in the denominator is x. So n is greater than m. So there's no horizontal asymptote. And n is equal to m plus 1. So we do have a slant asymptote. So we're going to do some long division. I'm going to kind of sneak it in here. We've got 2x squared minus 5x plus 7. And I'm going to divide that by x minus 2. X goes into 2x squared 2x times. And then I multiply it to both of these terms. So 2x squared, and 2x times negative 2 is negative 4x. And I'm going to subtract that. 2x squared minus 2x squared is 0. 5x minus negative 4x is going to be 1x. Negative x, negative 5. And I'm going to drop that 7, plus 7. X goes into negative x, negative 1 times. And I'm going to multiply that out, so I have negative x plus 2. And I'm going to subtract that. Oops, subtract that. 7 minus 2 is 5. That's my remainder. We're going to actually ignore that. This y equals 2x plus 1 is my slant asymptote. This is a line. My y-intercept is 1, so it's going to go through the point 0, 1, right there. And my slope is 2, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And this, then, is my slant asymptote. 2, 1. Oh, I think I did 2, 2, didn't I? There, 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 there. Something like that. Our asymptote intercept, so I'm going to set 2x squared minus 5x plus 7 over x plus minus 2 equal to our slant asymptote, which was 2x plus 1. If I multiply each side by x minus 2, and I FOIL this, I get 2x squared, that's negative 4 plus 1 minus 3x, and negative, or plus, that's negative 2. Subtract 2x squared from each side. I'm going to add 3x to each side. So I get negative 2x equals, I'm going to subtract 7 from each side. And that's going to give me negative 9. I might have done this wrong. 2x times negative 2 is negative 4x. Oh, that's a negative 1. Okay. That should be negative, because it's negative there. And that gives us 5. And so this ends up being an identity of 7 equals 2. So there is none there, and our domain then is going to be, our restriction is just that 2 on the vertical asymptote, so negative infinity to 2, and 2 to infinity. Let's look at the graph. So it's tucked inside the asymptotes.